Hi there and welcome to today's class. For today's class, we're looking at a very important and very basic topic in mathematics known as indices. Now, indices, in this video, I'll be teaching you everything you need to know about indices into the in-depth form of indices. Now, first things first, let's know what indices mean. Now, here's what to know. The term indices is a plural form of the word index, right? Of the word index. So what I'm saying is this: indices is a plural form. The singular form is index. So what's an index? By definition, an index is simply the power or the degree to which a number or a variable or a term is being raised. The number there is called the base, while the power is called the index. So let's say I have something like this. Let's say I have A multiplying itself, let's say 3 times. So A times A times A, this will be equal to A. A is multiplying itself 3 times, 1, 2, 3, becomes A to the power 3. So the index 3 here is called the index. So in this case here, I have A to the power 3. 3 here is called the index, while A is called the base. So here's what we can tell. The index tells us how many times the base is multiplying itself. All right? It's a very fundamental principle you need to understand. That the index is called the index, or it's called the power, or it's called the degree. All right, so please note that these are like the 3 names for it. So you call this the index, or the power, or the degree. And I'm saying that the index tells you how many times, this one is called the base, that the base is multiplying itself. It's a very fundamental concept you need to grasp. All right, now when it comes to solving problems involving index and indices, there are some laws that govern the concept of indices. So let's look at laws that govern indices. Laws that governs indices. Number 1, the first law that governs indices is called the multiplication law. It's called the multiplication law. All right. For the multiplication law, the idea is simple, that if I multiply the same base several times such that they have different index, my final answer will be to just sum the index or to sum the indices, and I'll have my answer. Now, what do I mean? For multiplication law, let's say I have A to the power 2 multiplying A to the power 3. This will be equal to, so I'm saying this one here, they are multiplying. If the same base they are multiplying, it becomes that base. My index now becomes the sum of the index or the powers, 2 plus 3, and that will be equal to A to the power 2 plus 3 is 5. So I have this. So this is what the multiplication law says, that if I multiply the same base having different powers or different index, my answer will be equal to that base, just sum the index, and you have this. That's the multiplication law. Let's take one more example. Let's say I have A to the power 2 times B to the power 3 times A to the power 4 times B to the power 5 times C to the power, let's say, 10. All right, let's do this one here using the multiplication law. This will be equal to, let me get the final answer. So I'm going to the final answer here. Let's get A. I'm seeing A, 1 and 2. So it becomes A into, we said sum the power. The power here is 2, here is 4. 2 plus 4 gives you 6 times, get for B. I have B here. The power of B here is 3. The power of B here is 5. So 3 plus 5 gives you 8 times C. If I look at this, I have just one C term, which is C to the power 10. If I combine this will be equal to A to the power 6, B to the power 8, and C to the power 10. So I have this. All right, so this is my value using the multiplication law. So note that I can only add the index or the powers if they are of the same base. So I cannot say this will not be AB to power 5. No. Why? They are of different base. So since it's A and B, they cannot add their powers. All right, this is the multiplication law of indices. Let's look at the second one there, number 2. Let's look at the division law of indices. Let's look at the division law of indices. All right, the division law of indices says that if I have two terms of the same base dividing themselves, my final answer will be to simply subtract their index or indices. All right, so for instance, if I have a to power, let's say 5, dividing a to power, let's say 2 in this case. From the division law, if I look at this, these terms here are of the same base. That's A and A. So I'll have A into subtract their parts, it becomes 5 minus 2, and that's equal to A to power what there? 3. So I have this. So this is a simple concept of the division law. If I have terms dividing such that they are of the same base, I would have to subtract their parts. That's division law. Let's take the third law there. The third law there is called the power law, right? The third law is called the power law. So let's look at the third one there. The power law. All right, let's look at the next one, the power law. For the power law, I'll just use a mathematical expression. For this, let's say I have a base A raised to power m, such that this term here is being multiplied by a number of times, let's say n. So we have this. For the power law, we say if you expand this, I have a base raised to a certain power and being multiplied by n times. My value will be equal to A into, for this case, you multiply the two powers. So it becomes m times n, and that's equal to A to power m times n is mn. This is the expression of the power law. Let me take an example. For example, I have A to power, let's say 3 all squared. Right. So I have A to the power 3 all squared. From here, this is the power law. It will be equal to A into this times this, 3 times 2, and that's equal to A to the power 3 times 2 is 6. So this is an expression of the power law. Please do not confuse the power law with the multiplication law. They are two different things. For multiplication law, we said if I have A to the power 3 times A to the power 2, in this concept, we are adding them. All right? This times this, we are adding them. So it becomes A to the power 3 plus 2, which is 5. Just as we said here. All right? Please do not confuse this with the power law. For the power law, we're saying if you have A to the power 3, that is being multiplied by n number of times. Right? This is multiplying itself by n number of times. I'll have this. Now, let me prove this a bit. Now, here's what to note. If we say we have x squared is equal to x times x. Okay? So if we now have A to the power 3 squared, A to the power 3 squared means whatever thing is in this bracket is multiplying itself 2 times. And that will be A to the power 3 multiplying A to the power 3. Right. Since something is squared, it's multiplying itself. So if this one here is squared, that means all of this is multiplying itself. It becomes A to the power 3 times A to the power 3. And if I use the addition law, if I use the multiplication law of indices, we said whenever two same base are multiplying, we add the power. So it becomes this plus this, 3 plus 3, and that's equal to A to the power 3 plus 3 is 6. So this, you can say this is here, is this. So we can say that the power law is an extension of the multiplication law. So we have this. Let's look at the next law of indices. Law of indices number 4. Let's look at the zero index law. All right. Our fourth law is called the zero index law. The zero index law says that whatever thing is raised to power 0, it's equal to 1. All right. So note that whatever thing raised to power 0 is equal to 1, but there's an exception to that rule. Okay? The only exception there is that if that term is not equal to 0. So I'm saying this. Zero index law mathematically states that any number raised to power 0 is equal to 1, provided that that number is not equal to 0. Please. All right. So anything all raised to power 0 is equal to 1, provided that that number is not 0. Okay, so what if the number is 0? 0 to power 0 gives you what there? An undefined term, or perhaps infinity, as the case may be. All right, so what this means is this. It means that if I have 8 to power 0, that gives you 1. If I have, let's say in bracket, minus 3 to power 0, that gives you 1. So I have this. Now, mind you, when you're working with negative, you have to be very observant. Observe that this is minus 3, all raised to power 0. The 0 affects both the minus and the 3, and that gives you 1. So I'm saying this. What if I had a minus 3 to power 0? This will be equal to, I'll have a minus, I'll have minus 3 to power 0 gives you 1. So I'm saying minus 3 to power 0 is equal to minus 1, but minus 3 all raised to power 0, such that the 0 is affecting everything there, including the minus. I'll have a positive 1. So this is something that is very, very important to note. All right. In this case, the 0 affects everything. So you can see in brackets, while in this case, the 0 affects only 3. So I'm saying this, that minus 3 to power 0 is not equal to minus 3 all to power 0. All right. Minus 3 all to power 0 is 1, while minus 3 alone to power 0 gives you minus, this gives you 1. So this is the zeroth law of indices. Let's look at yet another law of indices. All right, so let's look at the fifth one. The fifth one is called the negative index law. Fifth one, negative index law. Negative index law. All right, so this law states that if I have a base raised to a negative index or a negative power, it will be equal to the reciprocal or the inverse of that base raised to the positive form of that power. Now I'm saying this. If I have a base raised to a negative power, this will be equal to the reciprocal or the inverse of the same base raised to the positive form of that power. So I'll have this. All right, so this is the mathematical form or the mathematical expression of the negative index law. Let me take an example. So let's say I have 2 to power, okay, let me use 2. Let's say I have 2 to power minus 3, for instance. This will be equal to, of course, we said to eliminate the negative, I'll take 1 all over. So it becomes inverse of the base, which in this case is 2, raised to the positive form of the index. Positive form of this becomes 3. And that's equal to 1 all over 2 to the power 3 gives you 8. I have this. So this is how we solve problems on negative index law. Let's take one more example on this. Let's say we have 5 to the power minus 3, for instance. Okay, let me use minus 4, for instance. This will be equal to eliminate the negative, I'll take an inverse. So 1 all over 5 into the positive form of this, which is 4, and that's equal to 1 all over 5 to the power 4. All right, so I have this. 5 to the power 4 gives you, so 5 to the power 4 gives you 6 to 5. So I have this. My answer becomes 1 over 6 to 5. If you want, you can put this in decimal form if you want to, but that's not the case. Just know how we simplify terms involving negative index. All right, let's look at yet another law of indices. All right, so let's look at another law, the number 6. Let's look at what is called the fractional index law. Fractional index law. Let's look at this. All right. From the fractional index law, the mathematical form is this. Let's say I have a number or a base m to power m all over n. From this will be equal to the nth root of a. It becomes the nth root of a all raised to power m. So I'll have this as my mathematical expression, right? The nth root of a all to power m. This is the fractional index law. That's when the index is a fraction. This is how we simplify it. All right, I'll take an example and we do this. So let's say I have, let's say something basic, right? Let's say I have something like 9 raised to the power 3 all over 2, for instance. How do you solve this? This will be equal to, we said it's called the nth root, so it becomes the second root. So the second root of the base, which in this case is 9, all to power the upper one, which in this case is 3. Now, here's what to know, please. The nth root is when the number is 2, it's called the second root. And second root is the same thing as what is called the square root. It's called square root. So this becomes the square root of 9. So I'm saying that the second root of 9 is equal to the same as the square root of 9. It's the same thing. That means I'll look for a number that will multiply itself n times, which in this case is 2 times, to give you 9. And that number is 3, because 3 times 3, that's 3 multiplies itself 2 times, gives you 9. So it becomes this, they say this one here to power 3. So it becomes 3, which is the second root of 9 to power 3, and that's equal to 3 multiply itself 3 times, 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So I have this as my answer. Okay, let's take another example. Let's say I have 8 to power, let's use this time 2 over 3. Let's simplify this. How do you simplify this? Don't forget we said the denominator will be the nth root. So in this case, my denominator is 3. So it becomes the third root of 8 all to power the numerator, this, which in this case is 2. Now, by the way, let me stress something. Note that the third root of 8 is not the same thing as 3 root 8. Observe the way I'm writing this. What I have here, this 3 root 8. This one here is 3 root 8. Observe that the 3 is big and it's outside the square root sign. But the third root of 8 is written as a small 3 under this and then 8. These two are different. This one here is a sword, pronounced 3 root 8. This one here shows the third root of 8. All right, so it has to be a 3 under this sign. So observe the way I'm writing this. It's small and it's within this space. So it's called third root of 8. So don't confuse between third root of 8 and 3 root 8. They are different things. Right, back to this. So when we say the third root, when we say third root of 8, what do we mean? Now we said square root of 9 means a number that will multiply itself 2 times to give you 9, which you got as 3. So when we now say third root of 8, we're looking for a number that will multiply itself 3 times to give you 8. And which number is that? That number is 2. Because 2 times 2 times 2 gives you 8. 2 times 2, 4, 4 times 2, 8. That means the third root of 8 is 2. Now we'll now raise this, so third root of 8, which is 2, we'll now raise 2 to power 2. Okay? So 2 to power 2 is equal to 2 times 2, which is equal to 4. I have this. So this is how we simplify this. All right, let's look at one last law. Let's look at one last law, the seventh and the final law of indices. All right, the seventh and the final law is called the product par law. Product par law. All right, what does the product par law say? All right, From the product power law, what we have is this. If I have different terms multiplying themselves and being raised to a certain index, my answer will be equal to each of the term raised to that index. Now, what I mean is this. If I have x, y, z, now this is x times y times z multiplying themselves, all raised to power n, this will be equal to each of the terms. We take this. That becomes x to power n times y to power n times z to power n. This is called the product power law, all right? If I have different terms multiplying themselves, all raised to a certain number, it will be equal to each of the term raised to that number. For instance, let's say I have something like 2 times 3 times 4 all to power 2. Right. This will be equal to this to power this, 2 to power 2, multiplying this to power this, 3 to power 2, multiplying this to power this, 4 to power 2. So the 2 becomes the index of each of them, and that's equal to 2 to power 2 is 4, multiplying 3 to power 2 is 9, multiplying 4 to power 2 is 16. So we now have 4 times 9 times 16. If I punch that, 4 times 9 times 16 gives you 576. So I'm having 576 as my answer. All right. All right. So these are like the 7 basic laws of indices. In the next class, we'll look at how to use these 7 laws, how to combine these 7 laws to solve problems involving indices and also indicial equations. All right, so see you in the next class. All right, so to get all my classes on mathematics, physics, and chemistry, simply visit my site, my website, www.jonahimmanuel.com/courses, and look at the YX/JAM classes. And you see my courses there on physics, mathematics, chemistry, and other science. All right, so just head over to www.jonahimmanuel.com/courses, and you have access to over 50 tutorial videos on mathematics, on physics, on chemistry, and other science subjects. All right, then, see you in the next class.